Welcome to all aboard the Stateful train. So this is going beyond a simple web app with Elixir. So who am I? I am Eric Oestrich. I'm a wizard at SmartLogic. Who is SmartLogic? We build custom web and mobile apps. And we're based in Baltimore and have built over 150 apps since 2005. So this is kind of what we'll be going through. So we're going to take a look at what a standard application looks like. Why might you want to go stateful? What does a stateful application look like? Is stateful better? And then we'll see how we can go stateful. So this is a standard application. This is we use stateless HTTP. The controllers go straight to the database. We don't leverage OTP outside of what's given to us. You can think of this as like MVC or Rails-like, so model views controller. So it just kind of goes straight from your web request to the database and back out. So you get like WordPress, HubSpot, Wikipedia, Shopify, so blogs, CRMs, wikis, e-commerce. Typically will be just the stateful thing because you just want to look at a page, get it back, like click add to cart. That probably does something in the database. And then you check out mostly through a database and whatnot. So here's a stateful application. So we're still going to use stateless HTTP, but the addition is a long-lived connection. So WebSockets, TCP connections. We're going to make heavy use of OTP ourselves. And then you kind of think of these as like background processes. So stuff outside of the web request is what we're going to be working on. So you can think of like Slack, Discord, Twitch. Notice they all kind of have a real-time chat feature to them. So that's mostly where you would care about this. So OTP and processes. So this used to be the Open Telecom platform. It's been since unacronized into just OTP now. So it's the standard library of Erlang. These are the gen servers, supervision trees, ETs, and kind of all the fun stuff that you see around the internet of like different talks of like cool things you can do. So, and then processes are the base building block of Erlang and concurrency. So this is kind of what you might see. If you ever open up Observer, this is specifically out of ExVenture. This is the cache for items. So we have our items. This is a supervisor over here that then spawns off all of this. This is what CacheX gives you. So it kind of gives you a whole bunch of things that monitor your cache. So this is what we're looking at. So why might we want to go stateful? So we're on a platform that can handle it. Erlang is really good at this. Some things you might want, you can do local caches like CacheX. You will go to the database less often, or even to something like Redis or Memcache, you're not going out of the beam, so you're not incurring network costs for that. You can get better resilience because you can craft your supervisors to deal with pretty much anything. And if you go more stateful, you can make your website feel alive and responsive and like super cool. And again, did I mention Erlang is really good at this because it was built as a telecom platform. So this was just built like on a bunch of switches for phones. And if you're talking to someone, you don't want that to die. That's a long-lived connection. So yeah, that's why it's really good at this. So now we're going to take a look at some of the stateful applications that I have personally written. So we're going to start with ExVenture. So ExVenture is kind of way on the stateful side of this. This is a MUD server. You can go look at this at exventure.org. So before we get too far, what is a MUD? This is a multi-user dungeon, and specifically this is Dungeon, the 1976 text adventure. So this is just inspired as a multi-user version of that. So pretty much copy-paste with more people. So it's an online text adventure, and you typically connect with something you may not have heard of before. It's called telnet. Super secure if you don't know. So this is kind of what you would be looking at. This is Zork, the opening lines of Zork. So it just kind of describes where you're at. We're in an open field west of a White House with a boarded front door, and then you have a little prompt here, and you just type in your commands to maybe say go north, or look in the mailbox, get the thing out of the mailbox, read the thing that got out of the mailbox, like that kind of stuff. And I know no one pays attention during these, so if you want to go to midmud.com, this is a running instance of my ExVenture, so you can see kind of what this looks like and maybe play with other people. So ExVenture is a living world. Everything that is alive is a process. So the supervision tree, which we'll see shortly, each room, so this theater that we're in might be a process. You might go through a door to the room outside, which is another process. Backstage is a different process, and they're kind of all connected together. They're always alive. There might be some NPC processes that are wandering around. Maybe you have a janitor who's like cleaning stuff up, or you have someone who's giving the play on the stage, but that's not you. So you would connect in and be a character. You have your own process and a whole bunch of other supervision stuff. And this is always on. Just because you're not looking at it doesn't mean it's not doing stuff. So it's kind of just NPCs have brains and they kind of go about themselves and do their business. The database is only there for startup in this case. When ExVenture turns on, it goes and finds every zone that needs to boot. Zones are just collections of rooms. So it finds all the zones that should boot, spins them up. Each zone, when it starts up, has a supervisor that starts a zone process that then figures out what rooms should boot and shoves it in a side supervisor tree. And so when you start the world, everything is copied out of memory. It's like caches are warmed and all that. So database is mostly only there for startup. And there's lots of inter-process communication. So we can go ahead and take a look at what this looks like. So this is my local instance. So here's the website. We can go ahead and click play now. So this is actually using Phoenix channels instead of telnet, but this is kind of what we're looking at. So up here we can see we're in a hallway. This is a room. You've got your text describing the room. We have a little map of kind of the layout of the world, so we can go north, we can go south, north, and if we go east, we can see Bran here. We can greet Bran. Normally he would have a quest to give us, but I forgot to reset it, so this is what we're going to do. So he would talk to us, we would reply yes. Then when he gives us this quest where you got to go kill some bandits, so I happen to know the bandits are down here, so when we hit south, the bandit will target us and start attacking us. So this is targeting us, so we can go ahead and send him a magic missile. We'll heal ourselves, send him a magic missile, another one, heal, and hopefully one more and he'll be dead. There we go. So now he's dropped stuff in the world, so we can go ahead and look. So we can see the items there, so we can say get elixir, get gold, maybe we want to leave the potion. So now we can go north. And this is pretty much what you would do. We can see who's online and all that. And then the other cool feature of ExVenture is normally games, MUDs, you edit with something called OLC, or you can just edit pure text files in a very weird format if you feel up to that. But I went with a web admin, so we can go ahead and see everything back here. So here's the bandit, and we can see what it wants to do. So here's the events that make up its brain. So when someone enters a room, they're going to go ahead and target only players. And then combat will start once they target, and then this combat tick happens. So it'll go ahead and do a command skill of a slash, so it's going to slash at us with the same skill that you would use as a player. So this is kind of the cool features of ExVenture. Yeah, so could this be stateless? Like, not really. You could make something that's poll-based with some kind of like a worker that just ticks every like 10 milliseconds or 100 milliseconds or whatever, but you would definitely notice lag, and that just wouldn't be a good experience. And it's gross, right? No one wants to do that. So the next thing we're going to look at is called Grapevine. So this is a MUD community site. This kind of sits in the middle between stateless and stateful. Most of it is just a standard MVC app, but sections of it, which we'll see, are filled with state. So you can think of Grapevine as Steam for MUDs. The two big features of it are a cross-game chat and a web client for the telnet, so you don't have to install anything locally. And the cross-game chat kind of brings together a bunch of small, since most of these MUDs have 0 to 1 player, mostly on the 0. So the hope is that we can gather like 40 of them together. Any 2 of them might have that 1 player playing, and then they can start chatting with each other, and maybe they'll stick around their own game because they're interacting with people still, right? So that's the hope for that. So we're close to a standard application. All of the state is involved in the WebSocket and telnet, and a bunch of caches, mostly around presence of things that are currently connected. So let's take a look at what this looks like. So this is what you'd see if you go. This is at grapevine.house. It's the German spelling of house, so H-A-U-S. So this is what you'd see if you go there right now. I'm not connected to the internet for reasons, and so we just see a bunch of featured games. These are currently, as of like 7:30 this morning, this was what is connected. So we see there's 18 games that are connected. Syndome is kind of the big one right now, and then there's a few others that have a handful, right? So this is the cross chat, or the chat network, and then some of the other cool things you get. I scrape stats once an hour for these games. There's a protocol called MSSP, which is the MUD server stats protocol, and it kind of sends it through some like out-of-band telnet stuff. It sends like the number of players at 3 p.m. yesterday was 85, right? So that I scrape that, save it, and then you can kind of get some cool-looking charts of yesterday at 10 a.m. there was a minimum of 70, an average of 78 and 82. Sorry. For that 4-hour chunk of November 6th at 10 a.m. So this kind of compacts the last week. And then we can get the time of day. So this is the last week broken up into hours and bucketed. So at any given time, or any given day at 9 a.m., you might see this much players. So that's how you can kind of guess of like when a good time to play is. And it's kind of cool. Normally, you watch this, most of these games, I guess this might be different time zones or whatever, but most of them it's like as soon as work ends, it goes and then right back down right before work starts, so people just play all the way through the night. So this is now we're going to switch to my local copy, so we can go ahead and take a look at the web client. So this is a local test server, and this actually is pretty cool because what we just did there was OAuth through telnet, which is really weird. But it works, and hopefully it's secure. Yeah, so we're signed in automatically. Then we've got some kind of gauges down here. We can go ahead and start combat. This just randomizes each one of those and just kind of spits out some stuff. So we can just kind of watch stuff happen, right? And now the cool part of ExVenture and where the state, or sorry, Grapevine and where the state comes in is let's actually navigate away, right? We'll give this a few seconds. Our web client died, the channels process died, and we go back, play, and oh, look, we're still playing. So this is the power of state, right? So there's a separate telnet process that is actually connecting to your game that's communicating with the Phoenix channel. So it doesn't matter if your Phoenix channel is there or not, it's still connected, right? And then we'll stop combat. And the other feature, so we can see the chat, so we can say hello. So this is saying hello on Grapevine's web chat, so we're player at Grapevine. And then if we go over back to Spigot, the test app, we see here, Gossip player at Grapevine says hello. So we can go say howdy back, right? And we'll see that over there. So this is using the chat socket. So this is we're doing telnet to Spigot, and then Spigot is sending up through the WebSocket back. Yeah, cool. So could this be stateless? Like this is more easily stateful stateless than ExVenture. Like you could make some of the live caches, so that page that had all the online games, that could be in the database instead of talking to a process and getting it out of that. Like that's still gross. Chat applications like Campfire was famously poll-based every 3 seconds. It just checked to see if there was something new. So like that worked pretty well, and you don't really notice that bit of a delay, so like it could work, but like we can do better, so let's do better. So is Stateful better? Do I even want this? And that kind of depends. Like, you might not need this, so don't use this if you don't need this. But if you have a use case, then go ahead and do it. All right, so what are some of the pros? We can get, like, we have soft real-time capabilities. Erlang is built for it. So we can go ahead and use them. Your website can then go ahead and feel alive. Stuff can happen out of your web request and get pushed over through Phoenix channels, or just a Cowboy WebSocket if you're feeling brave. And you don't need to have a request response. You can reduce your database queries so you can do faster response times. So stay inside your beam with local caches instead of going out to the database or going out to a separate like Elasticache or anything like that. So some of the cons, like it's not all sunshines and roses. So this needs heavy usage of OTP. So you need to architect how your application is actually laid out instead of what Phoenix just gives you normally. So you need to learn about supervision trees and kind of different restart processes and whatnot, or restart strategies. So you need to thoughtfully lay your app out and make sure that if one rogue process starts crashing, gets into a crash loop, it'll bubble up and just take your whole application down. So you need to be ready and aware of that. Caches are hard. As we all know, there's two hard problems in computer science: cache invalidation, naming things in off-by-one errors. So this is we're just moving the cache from Redis or Memcache into the beam. So it's still hard, it's still there. So that's not going away. Your application is also going to most likely be harder to deploy. When your app starts, you're going to have to do a warm boot or warm your caches on boot. ExVenture, I did some load testing, and I think I had this is an insanely large world, but there was 20,000 or 30,000 rooms. So that's that many processes that need to start when you boot. So when you turned it on, it took 15 seconds to actually load, which isn't too much, but that's 15 seconds that you might be waiting, and you need it to be done beforehand, right? Your long-lived connections will also drop, so you need to make sure you're ready to deal with that. So for Grapevine, I push that onto my clients. So anyone that is connecting, when you sign up to connect, we can go look at the docs. The first thing that I state, expectations of a connecting game. I will go down because I'm deploying. This is not always going to be up, so just be ready for that. So you need to be able to deal with that, right? So you could have something on the edge that people connect to that you then talk into it, and that thing on the edge doesn't ever update, so you don't have to worry about killing it. So there's ways around it, but it's, again, harder to deploy. And then clustered applications need to handle a rolling restart, right? So what is a rolling restart? So we have all of our old nodes are at top. Then we'll surge to have a new node. Then we'll kill off an old node, surge a new node, kill off an old node, surge a new node, and then kill off the old, and we're just with new. So throughout this whole process, we also have to be aware that you're going to have old code and new code running in the same cluster. So you need to be ready for that and aware of that, and kind of just like the issue with doing migrations with old code, you have to this is kind of the same thing, but with message passing, right? And there's also a lot of other things that you might not be aware of, right? So mailbox size could be an issue. So if you have a single process that's getting bottlenecked, that mailbox will just keep filling up, and the more it fills up, the slower it gets, and the slower it can pull off, the more it starts bottlenecking until it eventually gets too big, it crashes and comes back, and maybe that crashes other things and has a bunch of ripple effects, right? Another thing to be aware of is that message passing copies the data that you have. So if you're sending a really big struct in a cast or a call, that's actually getting copied into the other process. So if you're doing that to a lot of other processes, you can bloat your RAM. I actually, while doing some load testing for ExVenture, I was just copying around a user struct that had a whole bunch of preloads, and I started getting up to the 200 player count. They're kind of all in the same small room, so each time a player enters, it sends a message to every other player in that room. So I'm copying all of this data. So I like crashed the beam at 60 gigabytes of like real memory. So that's like, you got to be ready for that, right? And then just kind of your normal clustering woes, the network drops for a second or whatever, and then like all that fun stuff, right? So that's not going away. So now we can try and go stateful. So you're going to use some gen servers. These are the basic building block. This is how you handle your messages out of the HTTP process, any kind of background tasks, and the state that you want to hang on to alive. Then we're going to have some supervision trees, so these watch over your gen servers, right? And then kind of the first thing you might want to reach for is ETS. So this is the Erlang term storage. It's got very fast reads and writes. It's concurrent, and the downside is that this also copies memory, so that might be an issue. So if we put this all together, we can kind of take a look at some of the use cases of ExVenture. So this is our very rough diagram of what the supervision tree looks like. There's a lot of stuff missing, but this gives us the gist, right? So we have our ExVenture as the application. It starts our Phoenix side. We have our HTTP, our WebSocket, and then we start the telnet stream, or the telnet process that's going to accept on a port for incoming connections, and then we have our world. So the world is watching a bunch of zones. The zones are watching a bunch of rooms and NPCs. And then we can go ahead and see if we connect in through the WebSocket, we're going to have a WebSocket process that starts an internal session that they then link to each other. And these links, in this specific case, you can kind of think of as like the parts where you'll mostly be communicating with each other. So anything that comes into a session will get shot out through the WebSocket, and then same with the reverse. So the telnet starts a session, they link together, and they just have a bidirectional communication. And then your session is your character that then goes ahead and then links to a room, and then they do a lot of talking to it. So you mostly talk to the room you're in, and that kind of acts as a router for other like players in there. And then we have our NPC also joins the room again. And so here's how we connect to the world. So we've got our client, our telnet process there, we have the world, and then a database column. So the important thing is to see how little we talk to that database column, right? So we connect, we start our process, then we authenticate. Hopefully you're not typing your password through telnet, don't do that. Then we go ahead and take the credentials that you just gave us, we check the database, say, okay, that is real, that's you, then we load the user out. Then your telnet process will then go ahead and display like a welcome screen. You'll press enter, and then we'll go ahead and enter the world for you. So we'll join the room, create that link, broadcast to other people that you're there, etc. We're then going to go ahead and do one of the few calls that ExVenture does is going to call the current room to get the state out to see who else is there. And then so that's the call, and then we're going to go ahead and display the room. So then it spits out, you're in the hallway, there's no one else here, right? And then we're going to go ahead and the player's going to enter a command, say move north. So that goes to the telnet. Then we're going to leave the room, enter the next room that we went to, and then fetch the current room again and display it, right? So in this whole process, we only talk to the database when you're connecting, and that's it. So that's kind of the important part to get out of this. We're dealing with only the state that is loaded in the beam. And this is kind of zoomed in to acting on the world. So we have our room column, our player, and then the NPC, right? So the player will go ahead and send a message. They're saying, I'm entering. The room will take that message and then notify everyone else in the room. So it's broadcasting out to the NPC. The player will go ahead and fetch the current state. And then the player will target the NPC because they want to kill the goblin. The goblin will go, ugh, and target back, right? And then we're going to send an attack. So this is actually a cast. It kind of bundles up all of the stuff that it wants to do, gives it to the NPC. The NPC will say, all right, like maybe I have some armor on or I have a spell, and I'll calculate and I'll readjust what you're actually going to do, and then I'll do that to myself. And that's why it's a separate respond back. So these are actually, they're both casts, so they're not a call. So it's going to send out, respond back, and then we're going to attack the goblin again, and then it's going to respond back, and then it's also going to say, oh, I died. And then it's going to leave the room, and then the room will notify the player that it's going to leave with a reason of died. And then the room will notify that out. You'll see goblin has died, spin up. So again, this is no database column here, so we don't even touch it. So this is all just internal state. So we can also check and look at how you might update a skill from the admin. So this is kind of the one spot that keeps with the like MVC style. So you go ahead and like, if we click edit on a skill, so we see all our skills, we click edit, that's going to load out of the database and display back. And then we're going to change some stuff. We're going to click update. That sends a post to the controller, which saves to the database. And then I have a PG notify, thanks to Todd, wherever he is. I stole this from him in his blog post. So there's a PG notify that's like waiting for updates on that table. It then gets it. And kind of concurrently, we're going to get this view skill. So then we're going to update, and then it's going to come back as what we just did. And then internally, we're going to load the new skill after we got notified, and then recache it in our cache for the internal game to use it. Right. So this is kind of the one spot that you're going to, like, I still wanted to use the database here because maybe you're looking at a node and you're just getting the local cache, and you don't, like, somehow we have to push into the database. So just loading it from the database in the admin panel seemed like a good thing to do. So here's how, like, if you're going to use Magic Missile, what happens here, right? So we have a player. So this is the actual person player, their session, the NPC, the skills cache, and then that lonely database column. So we're going to go ahead and we're going to type Magic Missile. That gets sent to the session. The session is then going to look up something that has the key of Magic Missile. We're going to load it from the cache. We're going to calculate all of our effects. Maybe we have some spells on us that might boost it. Then we're going to send our effects to that NPC. The NPC will calculate and apply its effects and then respond back and display. So again, no database column here. So now we're going to kind of switch to Grapevine. So we have the game that we're on, Grapevine, and the two other games over there. So we're going to go ahead and connect to Grapevine. We're going to authenticate. There's an event that you'll send to connect. And then from then on, we'll get roughly every 15 seconds a heartbeat to keep the WebSocket alive, and also do some kind of housekeeping. It's just, yeah. So then someone will go ahead and send a message, right? This uses Phoenix channels internally. We saw Sophie show us that we don't need to use the actual WebSocket part of connections of Phoenix channels to use Phoenix channels. So this just does a broadcast internally on a topic. So then we brought that broadcast out internally to everyone else's connecting Cowboy WebSocket, and then gets broadcast out through the socket. And then we can also do, so there's a few other API events that you can do. You can send a message to fetch all the online games, and then those will get blasted back to you. And this is all using just live connection, so like the presence tracker. So this is how the magic happened of navigating away from your running session and then coming back and still loading it, right? So we have our browser. Grapevine has two nodes. So we have a main node and then a telnet node, and then our game outside. So we're going to connect to our main node, which is running the Phoenix layer. It's going to start our WebSocket. It's going to then go ahead and talk to the telnet node and say, hey, start a session. That'll go ahead and connect, and then we'll get game data back. And I'll go from the game to the telnet to the main, and then back out to your browser. And then we can go ahead and we can close the tab. That will kill the WebSocket process. And then the game is still like we did not drop our telnet process that's connected to the game. So we're still receiving data from the game. We're going to go ahead and then connect back. It'll start its WebSocket process. And what it actually will try and do is see if there's a running session or start one. So we're going to find one that already exists. It's going to take it over. And then the game data that comes in now, and it will flow all the way through once again. So that's how that works. So for wrap up, Elixir gives you the tools to build stateful applications with ease. It's nice stuff on top of Erlang, and Erlang is really good at it, right? RAM and CPUs are cheap, so use them. And if you want an easy way into a stateful application, you can use LiveView. That gives you your own process, so you can do the pub sub outside of it and whatnot. And once again, you might not need this if you're just doing a e-commerce thing. You probably don't need a real-time chat for everyone looking at the new Switch game. to talk about how cool it is. Like, that's probably not a thing you need, right? So don't make your life harder if you don't need to. All of this is on GitHub. Oestrich on GitHub. You can go to Oestrich/X_venture or Oestrich/Grapevine. This is all open source. You can see the nitty-gritty details of how this happens. Yeah. I also run a podcast called Titans of Text. If you're into muds or mushes or moos, we talk with a bunch of currently running games and kind of hear some stories that are out and about, as well as we actually talked to Richard Bartle, who is, yeah, who is the creator, one of the creators of Mud 1, which was the original Mud that tried to rip off Dungeon, right? So that's at titansoftext.com. And then the thing you probably have heard, we're starting season 3 of Smart Software. Elixir Wizards. We're starting season 3 we've rebranded to Elixir Wizards pretty soon. So expect something later this month. Thanks.
Thanks, Eric. Are you also on the panel on Elixir Mix?
I am, yes.
Okay. So that's another way you can hear Eric's voice. Do we have any questions? Oh, there we go. I have one then when everybody's done, if nobody asks it.
I'm curious how you represent the maps. Like how do you like in that sort of structure? Like where do those relations live?
So like this?
Yeah.
So each room, go ahead and take a look at. So each room has an X, Y, and a Z. So that's how they get placed in that spot of like the map, and then you make exits. So this puts there's a database table that goes from this room to the hallway, and then it also creates a reverse. So if we clicked this X, it would delete both, and then it'll make both together. But eventually, you could just have one-way directions. And then to actually generate this map, it's super hacky, I feel like, but it kind of makes a 3x3 piece of text, and I like sticker them together, so they kind of overlay, and it makes a row, and then makes the next row, and kind of like puts it together. And if it's a blank space, it'll like let whatever was below it go through. So it's super hacky, and it works.
Thank you.
Yeah, I'm curious to hear a little more about how the different processes, the player sessions and the rooms and the NPCs find each other to pass these messages.
So it's mostly through the room process itself. So the player has in their like save data, it has what room they're supposed to be in. The NPCs have spawners of where they're supposed to start. So that's where they'll go ahead. Each I think I'm just using the global registry. So when a room starts up, it registers as global room, its ID. And so when it starts, the player process will start. It'll go ahead and join that. NPCs will join that as well. And then kind of after that, it's all through the room. So if they want to talk to an NPC, well, they'll fetch the current state, which will return that an NPC is in there, which has its PID, and then they can just kind of start talking. So yeah, that's how.
Anybody else? Oh, let me get.
So you said deployment is really challenging. Have you tried hot code swapping? And if you did, what went wrong?
So I mostly just didn't want to deal with it. Like Grapevine is a hobby project. Most of the applications that you or I work on can be down for a second, or we're doing load balancing, so one of the 2 or 3 can be down for a second. So just, I don't want to deal with the like upgrading in-memory struct, so it's totally doable, but yeah, avoid it, I guess.
Hi. Can you play entirely from telnet? Like
You
on
can,
the-
yeah.
So then a follow-up is how do you handle the drawing of the screen? Is it the same?
Hmm. So Mudlet is a Mud client, so this will actually use telnet. So if we connect to my local instance, I also have some debugging stuff on here, so we'll type Eric. This is how I get around not typing your password through telnet. And I'm already logged in, so let's close this. Was it reconnect? There we go. Type Eric. Authorize. It actually doesn't matter what you type there. So it's just it's using ANSI escape codes. So there's an internal language that I have. It's mostly HTML-like that you can kind of wrap things in color tags, and then on the way out through the telnet process, it'll colorize it, right? So it'll see that it's like bracket white, and it'll drop the code in for the like what's it /e bracket 33M or whatever it is, colon. So that's how these are all colored.
Cool. Is ExVenture the official chat client for Smart Logic?
We have to ask them about that.
Cool. Well, everybody give a round of applause to Eric.